Forces, problem set 4, question 7. A person pushes on a box with that amount of force. As a result, the box moves at a constant speed. We're supposed to draw a physical diagram, and skimming the problem, I don't see any requests to get a force diagram. I always recommend and expect that, even if I don't ask. Just to make sure we understand the situation. Here is my person. Mind you, I'm not trying to make it look pretty. They're pushing on that box, and maybe we've got some velocity that we want to show here. The force diagram for this situation looks like this. Let's see. Force gravity by the earth on the box. Force normal by the floor on the box. I was making sure the problem didn't refer to the ground or floor by any name. There's got to be an applied force by the person on the box. And at this point, I might be tempted to stop, except this note about constant speed. I know the forces have to be balanced. So I'm going to put that on the diagram and then attempt to decide what that missing force has to be. It makes the most sense that there must be friction. And there's a complete picture, force diagram-wise, of the problem. Part B asks me to find the weight of the box. Weight is equal to mass times the gravitational field strength. Do we know the mass of this box? Oh yeah, 5 kilograms. Fantastic. A reminder that when you're working on paper, you should always use a calculator. Reserve the approximations for times when you are working on a whiteboard or in person in class. The weight of this box is 49 newtons. Part C says determine the normal force on the box. I'm going to consult my force diagram here. When I do, I see that the gravitational force and the normal force, they need to be balancing each other out. I need to write that fact down. That's part of a well-reasoned answer. F net in the y direction is equal to F normal minus Fg, and that F net equals 0, coming from the fact that the forces are balanced 0. That means Fn equals Fg, at least in magnitude or size. Earlier we said that Fg was 49 newtons. That means that the normal force needs to be 49 newtons. So this one is up and this one is down. And that's apparent when you look at the picture on the force diagram, up, down. Part D, determine the frictional force opposing the motion of the box. Frictional force is here, so I'm going to write F net in the x direction is the applied force minus the frictional force, and that equals 0. Because the forces are balanced, this minus this equals 0. I was told how hard the person's applied force is, so FA equals FF. Friction force is 15 newtons, therefore. And that's to the left. Once again, these descriptions, left, up, down, They're not necessary. I just want to make a note for people who might have these questions, right? They're apparent from the picture what direction they travel in. Now, as a side note, an alternative way to solve this problem would be like so. And I recommend this alternative way for folks more on the visual side of things. You were told that this was 15 newtons. And I'm going to make one adjustment here because I was not specific before. Balanced X and Y forces. So by saying that the forces are balanced and this number being given, you can tell visually this has to be 15 newtons. I solved for that. This is solved because balanced given 15. This is mg 5 times 9.8, 49 newtons. And again, because we are balanced, I can say that this is 49 newtons. In order to solve the problem this way, which I think of as more of a visual solution, this is a required statement. If you're going to solve on a force diagram, I really need you to actually write that statement out for showing that you understand how to solve this problem. Either solution is good with me. You pick what speaks to you better. Again, this has been problem set 4, question 7.